1 second.
Sir?
No, ma'am. Balaji sir has not yet joined.
Please call Satya. Please call Balaji.
Yes, ma'am. I will call.
Ma'am, I have joined.
You have joined?
Ma'am, can you hear me?
Yeah, we can hear you. We'll go ahead with the. Are you ready with everything, sir? Can we go? Hello, Balaji sir, can you hear me? Can we start?
We are able to hear you, madam. Please go ahead. Please go ahead.
Yes, sir. Yes. Balaji sir, please be ready with the song.
Yes, ma'am.
Yeah. Yeah, I could see you. Shubha and Satya, go ahead, ma'am.
Yes, ma'am.
Yeah. Start.
I think I'm audible, ma'am.
Yeah. Yes, Shubha.
Yeah, okay, ma'am. Honorable dignitaries, learned delegates, respected faculty members, students, and my dear participants, a very good morning to one and all. I, Subhatra, Assistant Professor, Department of Biotechnology, and Dr. A.B. Satya, Research Associate, Department of Biotechnology, feel privileged to welcome you all on behalf of Department of Biotechnology, AVIT, and the Conference Organizing Committee for this two-day second International Conference on Recent Strategies in Biotechnology and Bioscience, ICRS-BBS 2021.
Prayer and the seed of faith are similar in nature. Both have nothing within, but have the potential of creating everything. So let us start this occasion with a prayer song. Thank you all.
Well, Albert Einstein said, if we knew what it was we were doing, it would not be called research, would it? It is one such occasion like this. We get opportunities to get an exposure about recent strategies in biotechnology and bioscience. Without further ado, let us proceed with the inaugural ceremony.
People don't always need advice sometimes. All they really need is a hand to help, an ear to listen, and a heart to understand them. I would like to invite one such person, our beloved HOD, Dr. R. Devika, Department of Biotechnology, to deliver the welcome address.
Thank you, Dr. Satya. Respected Principal, Dr. Selvakumar, Director Research, beloved Dean, CSR, distinguished chief guests, and keynote speakers of the day, HODs, delegates, faculty members, students, and friends. Happy morning to one and all present here. With great pride and honor, I take this esteemed opportunity to welcome you all for our second international conference on research strategies in biotechnology and biosciences. It gives me immense pleasure in welcoming our revered principal, Dr. G. Selvakumar, who has a great vision in bringing AVIT to greater heights globally. Welcome you, sir. It is a great honor to welcome our beloved Director of Research, Dr. S.A.V. Satyamurthy, sir, who is a driving force behind us in all the research activities. Welcome you, sir. With great enthusiasm and gratitude, I welcome our evergreen, energetic Dean, CSR, Dr. Giri Rangasamy, who is our mentor in all the endeavors of our department activities. Welcome you, ma'am. It is my great privilege to welcome our two distinguished educationalists and chief guests and key note speakers of the day, Professor Dr. Kalaimati from Florida International University, Florida, USA. Welcome you, ma'am. And Dr. Chris, co-founder and CEO of Global Opportunity Commercialism, Director of APAC Health, and Managing Director of Mainstage Incubator, Australia. Welcome you, sir. I take this opportunity to welcome all our vice principals, heads of the department, faculty colleagues to this function. Welcome you all. With great excitement and happiness, I welcome all the delegates and students from various university colleges to our conference. Welcome you all. Once again, I heartily welcome you all to this conference and hope this conference will definitely reach its success with great educational and informative experiences. Thank you all.
Thank you, ma'am. A leader is one who knows the way, goes the way, and shows the way. Here is one such leader who leads us in a right way. I'm elated to welcome Dr. G. Selvakumar, Principal AVIT, to deliver the presidential address. Sir, please.
Thank you, and very good morning to you all. Really, it gives me pleasure to take part in the inaugural ceremony of the second international conference on recent strategies in biotechnology and biosciences. I congratulate the Department of Biotechnology for taking this initiative. You know, organizing the conference once itself is a great task, and doing it for the second time is really tough task. And during this pandemic, it's able to do it. So, congratulations to the HOD and coordinators of the program. And I really take privilege in welcoming the chief guest of the day, Dr. Kalaimati, professor of Florida International University, Miami, Florida. Welcome, ma'am. So I extend my warm wishes on behalf of the management and my own behalf. And I also welcome Dr. Chris, the co-founder and CEO of Global Opportunities and Commercialization, and the managing director of Mainstage Incubator Australia. Welcome, sir, to this conference. And I take this opportunity to welcome our beloved Director of Research, Dr. Satyamurthy, Director CSR, Dr. Giri Rangasamy, and the HOD of the Biotechnology Department, Vice Principals of our institute, and faculty members, participants, the paper presenters, and the students of our institute as well as other institution and guests to this inaugural ceremony. So I don't want to take much of your time because there are eminent people to talk about biotechnology. I'm an outsider. I'm an electrical man. So I just want to wish this. And I need support of the personalities here, Dr. Kalaimati and Dr. Chris. After I assume office of the principal, I'm motivating the students towards entrepreneurship. And our management has already established an incubation center in our campus. And we have got a lot of credentials in terms of getting the recognition from various government agencies, particularly the Ministry of Micro, Small, Medium Enterprises, Government of India has recognized our institute as a business incubator, and they are also ready to fund our ideas to the tune of Indian money 50 lakhs. So a lot of things are happening, and we need the support of the eminent personalities here to take it forward, not to take to convert most of our students into entrepreneurs. With this note, I once again wish this conference all the best. I hope a lot of fruitful deliberations will happen in this conference, and there will be a lot of takeaways for the researchers. Please don't stop with theoretical research. That's what I mentioned in all the conferences. Try to go up to product development and technology transfers, and that will really help India to climb the ladder, and it will become a superpower very soon. So with this note, I thank everyone for the opportunity given to me. Thank you.
Thank you, sir. Thank you very much. The experience of the elderly can be of immense use for the nation. We also have a person with immense research experience who guides us always. I'm honored to welcome Dr. S.A.V. Satyamurthy, Director Research, VMRF, to deliver the special address. Sir,
Thank you, Dr. Satya.
thank you, sir.
Respected Professor Dr. Kalaimati, respected Dr. Chris Sotiropoulos,
நான் ஒரு ப்ரோக்ராம்ல இருக்கிறேன் அப்புறம்
respected Dr. Giri Rangaswamy, Dr. Ramanathan, Dr. G. Selvakumar, Principal ABIT, Dr. R. Devika, HOD Biotech Department, Vice Principals, HODs, faculty members, delegates, and students. A very good morning to all of you. It's my pleasure to participate in this second international conference on the recent strategies on biotechnology and biosciences. I, as a researcher, always feel that at a periodicity, we should take stock of situation of where we are in that particular domain and check out the future program for our research activities. I personally feel that though biotechnology as a department or as a science is existing for quite some time, its full potential is yet to be tapped. Yet to be tapped for the betterment of the mankind. The order of the day today is going for collaborations with other faculties, other departments for doing multidisciplinary research. In fact, Principal has rightly mentioned that doing theoretical research and publishing some articles, yes, that is important, but that's only just one part of it. You have to convert into a practical research, make into a product, and make it useful to the mankind in general. And we have all the facilities thanks to our management. But if biotechnologists sit in their silos and if you do a good job, it will not reach the world. As you know very well that Ayurveda and Siddha were invented in India centuries back, and we were the leaders. And in those days, the doctors from Ayurveda and Siddha were able to cure many ailments, and people were quite happy. We lost the race in the last 1 century to allopathy. It's not that I am against allopathy. People wanted quick solutions, even at the cost of side effects. If biotechnologists can join hands with our pharmaceutical faculty, medical faculty, and come out with some solutions, especially some herbal medicines for the ailments that are the people are burdened with like cancer, diabetes, hypertension. There is nothing like that. As I understand, the herbal medicines have very little side effects or no side effects and highly affordable, unlike allopathic medicines. And also there are many new areas to explore like nanomedicine, biopharmaceuticals, marine biology, biosciences, etc. And you can't get a better place than AVIT to do all this research. We have full support from the management, and we have to deliver. This nanotechnology in nanosciences in biotechnology is not something very new. People from old generation may be knowing that Tangabashtam was used for some of the aging solutions, and that is made of nano powder and was existing for centuries, and it is made of nanotechnology. Again, thanks to the management that we have a very good nanotechnology lab in AVIT. We should make use of this particular facility, and I want our biotechnology faculty to sit in the nanotechnology lab and make use of it in full spirit. Also, a time has come where we have to collaborate. We have to collaborate with our own faculty, and VMRF is blessed with having 13 faculties of varied disciplines, starting from medicine, engineering, pharmacy, and many other things. These three things, if you just collaborate together, so for example, medicine, pharmacy, and biotechnology colleagues can formulate and come out with a problem. I am sure that we will be able to find many practical solutions to the problems which are haunting the mankind. I can put all efforts and be a catalyst for forming these collaborations with medical colleges of our own VMRF and pharmacy college of our own VMRF. I also request Dr. Devika and Dr. Giri Rangaswamy, who is always a mentor and a well-wisher of AVAT, to find time in this coming 2 days to find out and have discussions with faculty from national and international universities to identify certain areas for collaboration. And in fact, after Dr. Selvakumar has taken, we did enter into certain collaborations, and I feel University of Florida is well known throughout the world. If Madam can help us in having some collaboration, I always feel that 1 plus 1 is 3. It's up to you whether you make 1 plus 1 is 0 or 1 plus 1 is 3. I always feel that with a positive mind, with mutual trust and respect, we can always make 1 plus 1 is 3. So if we collaborate and if we collaborate and do research, I feel that the results will be able to get much faster, and also there will be peer pressure and peer competition. So we should take advantage of our own university and other universities, and I hope in all the areas which I have mentioned, we will be able to come out with some problems and work on that. And but Dr. Devika and all the faculty, I know them very well. They are very proactive and very much research oriented. I hope this conference will trigger them to do much more. I wish the conference all success, and I hope this today conference will have very fruitful deliberation. Thank you very much.
Thank you, sir. Life became easier when you have right people on your side. We also have one such eminent person by our side to lead and guide us. I'm privileged to welcome Dr. Giri Rangasamy, Dean CSR VMRF TU, to deliver the special address. Ma'am, please.
Very good morning to all of you. A special welcome to the Kalaignar. I'm really delighted to participate in this two-day international conference on recent strategies in biotechnology and biosciences. I really feel happy that the department under the leadership of Dr. Devika is very active and vibrant, even when the entire world has slowed down its activities due to the pandemic. I would like to start with the poem by Tiruvalluvar, which says, எப்பொருள் எத்தன்மை தாயினும் அப்பொருள் மெய்ப்பொருள் காண்பது அறிவு. That means whatever it is, what kind of information it is, always it's better to find the ultimate truth, and that is considered real wisdom. So I think right now we have a lot of speculations and suggestions and concepts and technologies in the field of biosciences. But as educators, we would like to give the latest information which is genuine and authentic. This is achieved through conferences like this, with an international networking where experts share their knowledge on concepts and innovations highly updated. Now, what is unique about Arupadai VV Institute of Technology, that is our college? I always felt that our faculty, our principal and the faculty, they not only engage not only are engaged in classroom teaching, but also believe in promoting extracurricular and co-curricular activities involving the faculty and students. And certainly, AVIT plays a very significant role in fostering knowledge, skills, and society.
You got muted, Dr. Giri.
Ma'am? Dean, ma'am?
Now, can you hear me?
Yes, ma'am. Yes,
Hello?
ma'am. Yes, ma'am.
Now, can you hear me?
Hello.
Okay.
Yes, ma'am.
Okay.
Yes.
And our college certainly plays a significant role in fostering knowledge, skill sets, and societal values to the younger generation. No doubt that the advancements in science and technology pose very great challenges as well as opportunities in upgrading the knowledge sharing in the higher educational institutions. Through these international conference, the college and the department feel that the staff and students are globally connected, and it seems encourage the youngsters to support teamwork, coordination, and handling responsibilities, and prepare them for socially viable activities and services during their academic pursuit in the college. I'm sure the objectives of this international conference are critical thinking, concept development, innovative technologies, and quality education. To quote a few upcoming areas of research in biotechnology and biosciences is stem cell research, human genome project, targeted cancer therapy, 3D visualization for surgery, vaccines, development of vaccines, organ transplants, and so on and so forth. So this conference aims at giving the updated, valid, genuine information to the younger generation who are also research oriented. I congratulate the organizers for having worked very hard to make this program, 2-day program. And I wish them all the very best of luck. And I appreciate the work done by the Department of Biotechnology. And I'm very happy that we could rope in some of the experts from abroad. And that gives us a lot of encouragement and happiness. So I wish one and all, the participants as well as the resource persons and the faculty of our college, a grand success. Thank you.
Thank you, ma'am. Thank you very much. I'm happy to invite Professor Dr. Kalaimati, Florida International University, Florida, to release the conference proceedings on this virtual platform.
Thank you for the invitation. And let me add my welcome to all the participants, the dignitaries, and congratulations to the organizers to pulling this together. And I officially released this conference proceedings for the second international conference on recent strategies in biotechnology and biosciences. And I wish you all the very best in everything you do here and now and in future.
Balaji sir, can you scroll down for some after message? Thank you. Go ahead, sir. Thank you, sir. Thank you, sir. Thank you, ma'am.
Thank you, ma'am. Thank you very much.
You're welcome.
Further, I would like to invite Dr. B. Prabhasila, Associate Professor, Department of Biotechnology, AVIT, co-convener of this conference, ICRS BBS 2021, to deliver the note about the conference.
Thank you, Dr. Satya. Good morning to one and all present. I, Dr. Prabhashila, would like to elaborate about the conference. In the wake of the recent development and new demands on the science and technology system, it is necessary for us to embark on some scientific deliberations which have relevances to national needs and for tomorrow's technology. The Department of Biotechnology has a pivotal role in promotion of science and technology in the country, thereby organizes the second international conference on recent strategies in biotechnology and biosciences, ICRS 2021. It is a two-day virtual conference, the first international conference on recent strategies in biotechnology and bioscience was held on 24th and 25th April 2017. The second international conference, ICRS provides a global platform to interact the critical emerging issues and to explore, widen the scope of interdisciplinary research among academicians, researchers, and industrial personnel in the field of biotechnology and bioscience. The thrust area includes nanotechnology, sustainable energy, health and disease, agricultural science, environmental biology, marine biology, system biology, biotechnology, and bioengineering application. The conference has received more than 200 registration and 46 papers for oral presentation across the globe, both from engineering and arts and science colleges like Government Arts College, Karur, Oxford College of Science, Bangalore, ICAR, Banariaman Institute of Technology, Satyabama Institute of Science and Technology, Massa University, Malaysia, Stella Maris College, St. Mary's College, Srinavalli, Sri Sastra Institute of Engineering and Technology, Sri Venkateshwara College of Engineering, Sri Tyagaraja College, Chennai, Ethiraj College for Women, Vinaya Missions College of Pharmacy, VMKV, Rajas Durai Singham Government Arts and College, Azan Memorial College of Arts and Science, Raja Sarapoji College, Tanjore, and Amrita Vishwavidya Peedam, Coimbatore. At this juncture, we would like to place a note of gratitude to all the participants. This two-day conference includes deliberation by our eminent speakers, Dr. Kalai Mathe, Florida International University, USA, on vaccine, drug, bug, and black fungus. Dr. Chris, co-founder and CEO, Global Opportunities, Director of Health and Managing Australia, will spotlight on artificial intelligence to detect and minimize the impact of next global pandemic. Dr. V. Ashok Kumar, Department of Chemical Technology, Chulalongkorn University, Bangkok, will give a lecture on biomass, on sustainable energy and byproducts. Dr. Prakash from Crescent College of Pharmacy, Dr. Selvaraj, Bioscience Research Foundation, and Dr. Asaq Hacker, National Institute of Tuberculosis, Chennai, will chair the oral presentation. Dr. B. Ramanathan, founder and managing director, ACE International Singapore, will give a valedictory address. Best three papers will be awarded. All the registered participants will be provided with certificate for participation and presentations, and the abstract will be published in the proceedings with ISBN number. This is a great opportunity to share your knowledge throughout the world profile. I would like to end up with a quote: research is to see what everybody else has seen and to think what nobody else has thought. Thank you.
Thank you, ma'am. Without further ado, let us enter into the technical session of the conference. I would like to invite Dr. R. Balachandar, Assistant Professor, Grade 2, Department of Biotechnology, to introduce our chief guest for Technical Lecture 1, Professor Dr. Kalemati, Florida International University, Miami, Florida, USA. So please.
Thank you. Good morning, everyone. I feel immense pleasure to introduce today's our chief guest, Dr. Kalimati, Professor of Molecular Biology and Infectious Diseases, Herbert Wellington College of Medicine, Florida on this occasion. She completed her PG degree from University of Malaya, completed her PhD and a Master of Public Health in USA. She completed her postdoctoral training at Tufts University in Boston, Memphis, Copenhagen, and Denmark. She has more than 20 years of teaching and research experience. Her area of research in molecular biology and infectious diseases. In 2010, she became the professor of molecular microbiology and infectious diseases, first faculty member and founding chair of the Department of Molecular Biology and Infectious Disease at Herbert Wellington College of Medicine in Florida International University. She is also the founding director of Florida International University Global Health Consortium, first Florida International University faculty member elected to the prestigious Fellow of the American Academy of Microbiology. She is the second and the first woman who was also educated in her vernacular language of Tamil. In 2011, she was awarded the President's Council World's Ahead Faculty Award, the highest honor at Florida International University. In 2014, she was one of inaugural recipients of New England Biolab's Passion in Science Award for scientific mentorship. Her publications record crossed over to 150 publications, 5 patents, and 120 invited lectures and presentations. Many of her articles appears in high impact journals, including Proceedings of National Academy of Sciences, Annual Review of Microbiology, Nucleic Acid Research, and Nanoletters. She has been elected chair of many international scientific conferences, including the top biennial Pseudomonas Conference and the Asian Conference on Transcription. On behalf of Department of Biotechnology, once again, I welcome you, madam. Thank you.
Thank you, sir. On behalf of Department of Biotechnology, I would like to invite Dr. G. Selvakumar, Principal AVIT, to honor the guest, Professor Dr. Kalaimati, with an e-memento. Sir, please.
Please share back. Who is sharing, madam?
Balaji sir is sharing. Balaji sir? Yeah.
So as a token of love and appreciation, we present the e-memento. Kindly accept and do the honors, madam.
I thank you for the memento. This is quite something. I appreciate it very much.
Thank you.
Thank you, sir. Thank you, ma'am. Now I would like to welcome Dr. Kalaimati to deliver her technical lecture. Ma'am, please.
All right. So good morning to all of you. And let me once again welcome all the guests, all the honorable guests and participants. And thank you to Dr. Devika for inviting me to join you here. And I certainly pleased to hear all the things so far. And I also think that whether my talk is the appropriate talk for this session, because the what Dr. Satyamurthy was saying was, where he would like to take the institution, and perhaps I should have given a talk on my ongoing research projects in the lab. However, last year, since the COVID-19 started, I've been giving series of lectures on COVID-19, and I keep updating and I keep going, being asked to do these same lectures. So here it will be literally up to date as of yesterday or today for you. So briefly, I do represent the Florida International University, which is in Miami. And I also, as editor-in-chief, and I do represent the Journal of Medical Microbiology, which is the part of the Microbiology Society journals. And Microbiology Society itself is based in London, United Kingdom. So this is going to be, I have about 40 minutes, I believe. And let me get my phone. So I set up my time. So it's 12:40. So we'll see if I can finish it. So this is a brief outline. I thought, since I'm speaking to this particular group as a first time on this topic, I would give some outline on vaccine history and a little bit talk about 21st century vaccines. Perhaps that's the most biotechnology aspect of my presentation today. Then we go into more on the COVID and SARS-CoV-2, talk about the vaccines, and then talk a little bit about the vaccine status, in India, and talk about shortages and address antivirals and black fungus. I am going to be very mindful of time. So if I think that I don't have time, I might pass some of the slides. So it's 12:40. So we have until 1:20. I should stop, right, Dr. Devika? I should stop at 1:20 or 1:15.
Yes, ma'am. You take your time, ma'am. Because I don't want to.
Okay. All right.
You take your own time, ma'am.
All right. So first of all, the disclaimer is I am not a medical doctor. I am a PhD and I'm a scientist. I'm able to look at things more critically, and that's what I bring to the table here. So if you think you have concerns, you should certainly consult your doctors, but I would highly recommend that do some research to find out what you're hearing is real or not. So you can't talk about vaccines without thinking about smallpox. Many of us have never seen, or maybe some of us have seen, older adults who had suffered and survived. It is a devastating disease with a very high fatality, and it is by a DNA virus, variola. And there's no cure for this virus. In fact, most viral infections have no cure. And so the only way to stop it is prevention. And we know that preventative measures against smallpox dates back, it's a very old thing. And you see that back in 1080, in China, they were already introducing variola into humans. They take a dry skin from an infected person and they'll blow it into the nose. This is a form of vaccination. And since I don't have time to go through everything, all I can say is that back even in 1545, there were reports that people in India will scratch the skin and introduce the scabs of people with smallpox. And that is, it is a vaccination, before we had intramuscular injections. But this vaccination against smallpox was really made popular by Lady Montagu, in London when she learned about this whole process in Turkey, where her husband was an ambassador. But I think fast forward, in 1749, Jenner was born. And we all know that Jenner is the father of vaccines. And what he did was, he was a very good scientist. He was very observant, and he observed that the people or the milkmaids who had previously had cowpox were immune to smallpox. So he did the experiment. Of course, you can't do this these days. You introduce without any IRB. And so he protected this young kid, 8-year-old kid, with smallpox and cowpox by vaccinating him. The process is now called vaccination, and the vaccination comes from word vacca, which is Latin for cow. And apparently his friend Richard Dunning coined the term. Of course, people thought that he's crazy, he's repulsive, ridiculed him. They refused to publish his paper. And those days, if you can publish it if you have money. And in the end, he did publish his paper on his own money. And then the rest is history. In 1840, there was free vaccination to all infants in United Kingdom. That's the beginning of a mass vaccination. And now, everybody accepts vaccine as a norm. Many a childhood vaccination protocols are heavily followed all across the globe. So there are 5 types of vaccine, right? That when and one of the first vaccine that was developed, and I'm going to go through them very briefly, and live attenuated, inactivated subunit vector and mRNA. And this is really, shows the development trend in terms of how science and molecular biology and biotechnology has taken to where we are now. Live attenuated is simply you grow the bacteria or the virus many times, you passage them sufficient times so that they no longer cause disease but still can cause infection, right? So it can grow but not cause the disease. And of course, the famous BCG vaccine against TB is also live attenuated bacteria. And then we had inactivated vaccine, where the whole virus, you boil it, and then you create a concoction, then you introduce in people. And when this came across, after we learned that, the immune response doesn't have to see a live bacteria or live virus. If we get any inactivated protein, it will work. So then this whole bacteria, where you can also inactivate the whole bacteria or whole virus, doesn't matter, but you can boil them, and because it has all the component that our immune system will see and respond. And so in more recent years, of course, is this subunit vaccine. Instead of giving the whole bacteria, the whole virus, let's find out the most active immunogenic component of the bacteria or the virus. So you can specifically take a one protein which is on the surface, or something that get released by the bacteria into the medium, then you can make a vaccine. And another example is the toxoid. Toxoids are basically boiled toxins. And these toxoids, you can just use the boiled toxin, so it's not toxic, but our body sees it as foreign and creates antibodies against it, and then also subsequently memory, so that if the organism such as Clostridium tetani enters your body will immediately fight back and say, you shouldn't be here, I'm going to get rid of you. And then the recent years, of course, we have the polysaccharide vaccine. It's basically the polysaccharides on the surface of this bacteria, which are highly polymorphic. There are too many serotypes. So what they do is they combine all of them and create vaccines. And then now we turn to 21st century, which is this recombinant vector vaccine and mRNA vaccine. And I'm going to talk about both of them a little bit more detail. So before I go into recombinant vector or mRNA vaccine, just a brief background, and I apologize for those if it is too basic. We know that all genomic information is on the chromosome, and the genetic material is mostly in the DNA, except in some viruses. And we know that the thing, what our host system, that our body sees, is the protein, not the DNA, not the RNA, but the protein that it will create antibodies against. So we have the information in DNA, which transcribe to RNA in most cells, including our body. But what happens in the viruses, some of them has a RNA genome, right? This is when, excuse me, such as flu and SARS-CoV-2 virus. So SARS-CoV-2 has a RNA genome. And remember this because it becomes relevant when I talk about it this later. So with that information, let's look at the SARS-CoV-2 virus. So this is again the technology development is so fast, and the 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 speed at which we can isolate the pathogen, sequence it, and image it is like, it's literally within a week you can do, or even less. So as soon as we figured out that SARS-CoV-2 or this pandemic started, we immediately, the virus was isolated, sequenced, imaged, and we know that it has a RNA genome. And importantly, you see these red proteins that's on the surface of this virus, and this is called the spike protein. And so when the virus enters your body, the first thing the immune system, what I call them the foot soldiers, see is this protein outside the virus. So this protein is important because this protein is actually called the spike protein that actually makes contact with the host receptor, which then allows the virus to enter the host cell. So if we can stop this spike protein from binding to the host cell, then you can prevent the infection. So that's the whole basis behind generating antibody against this spike protein. So what is the vectored or the DNA vectored vaccine? You basically, instead of purifying the spike protein and introducing, if you're a biochemist, you know it's no joke purifying a vaccine protein. Not only you have to overexpress it, and you have to purify it so clean and make sure it's free of everything in it, and then after that you have to make sure it is in the right form to give it to create the vaccine product. However, and this again, I want to emphasize that this is not a new technology. They have been working on it for a long time, and they developed it for Ebola, which is almost 10 years now. So the work has, in fact, dates back to 20 years. So what they decided is, let me take the gene for the spike protein, right, and introduce it to a virus. And this virus is adenovirus, which causes mild cold-like symptoms to most humans. And what they do is they put the DNA, of course, there's a DNA virus, and the virus will get internalized by the host cell, which then will get to the nucleus, where it will inject the DNA sequence into the nucleus. And in the nucleus, the DNA gets transcribed, and the mRNA then comes out into the cytoplasm, which then get translated into the spike protein. Now the whole spike protein is made, which will go to the surface, or it can also be presented to the immune system through these spike protein fragments. So this is the DNA vector vaccine. And when people talk about some of this vaccine, so the choice of this adenovirus differs from vaccine to vaccine, okay? And how about the mRNA vaccine? So instead of me telling you the story, I am going to play you a video. Please let me know if the sound system is okay. This is what we should. Can you hear? Can you hear Dr. David? Dr. Devika, can you hear the video?
No, ma'am. No, ma'am.
No?
Here.
Hang on. How about it?
No.
In China. The corona
Yes, ma'am.
and its genetic information was uploaded to a public database. Working together, scientists at the NIH and Moderna identified the sequence for a key protein on the surface of the virus called the spike protein as a good vaccine candidate.
You can hear the sound, but there is
The
no
spike
video.
protein were then encoded into
Pardon?
an instruction molecule.
You can hear the sound, but there is no video streaming.
Video. Yes, ma'am.
Oh, really? Sorry.
Only the sound is.
Okay. I understood. Yes.
Yes, ma'am.
Yes.
Maybe you can start to share the video window.
Yeah, I'm doing it. Yeah.
Yes.
Yes, ma'am. Yes, ma'am.
Perfect.
Okay.
It all started with isolation of the virus from an infected patient in China. The coronavirus was sequenced and its genetic information was uploaded to a public database. Working together, scientists at the NIH and Moderna identified the sequence for a key protein on the surface of the virus called the spike protein as a good vaccine candidate. The instructions for making the spike protein were then encoded into an instruction molecule called mRNA, which could be administered directly to patients as a vaccine. The vaccine is injected just like other vaccines. The mRNA is taken to immune cells, where it instructs cells to make copies of the spike protein as if the cells had been infected by the coronavirus. Other immune cells, shown here as red and orange figures, are then able to learn about the spike protein and develop ways to protect the person if they ever come into contact with the actual coronavirus. What makes this approach different is that you don't need to make the virus itself to make a vaccine, a time-consuming and intensive process. Instead, you use the information from the virus and administer the information directly to the patient. Essentially, the patient makes their own vaccine. This cuts out the middleman. Using this approach, NIH and Moderna were able to go from sequence to a vaccine ready for human testing in record time, just 42 days.
So I'm going to go back to my talk. So from the video, you realize that the development of the RNA vaccine was much faster. And if you know, in the process of extracting DNA is we know how to do it. It's very easy. And then it's a little harder, but extracting RNA is easier. But in this case, if you're synthesizing, you get pretty cell-free RNA, which then can introduce into the host. So I want to want to make sure that we understand the vaccine is not against the COVID-19, but the vaccine is against the virus, and the disease is what we call COVID-19. And the COVID-19, and you all probably already know, there are many common symptoms, which are dry cough, fatigue, fever, and muscle ache. And then there are uncommon symptoms, including loss of taste and smell, skin rash. And that the severe symptoms that everybody suffers from is the shortness of breath. And we will talk a little bit about that in the later slides. So here is where COVID is as of this week. In terms of hotspots, and you can see South America, the Southern African countries, as well as European countries where it is very high. and Southeast Asia. So these are where hotspots are. And in fact, the darker the red, those places, the cases are increasing, which means that it's good. In India, the color is lighter. It looks like the number of cases are stabilizing in India. But if you look at the number of cases as of today, we have 194 million cases and about 4.1 million deaths, confirmed deaths across the globe. And the three leading countries, and as you can see, number leading is USA, that's followed by India, and then that's Brazil. And in terms of number of deaths, we still have very high number in US, followed by Brazil and India. And remember, in US felt the COVID a year ago, and we started losing people. And then now the wave has started in the east, and we are worried that it soon the cases will increase. India and Brazil will bypass the US. And also in the US, more than 70% of the people have already been vaccinated. How about India? The India hotspots are Kerala and states Manipur and Mizoram and Arunachal Pradesh. This is where the hotspots are. In terms of cases, the most cases are in Maharashtra, which is largely driven by Mumbai. And then here's the numbers for Tamil Nadu. There are about 2.5 million cases in Tamil Nadu. And if you look at the deaths, there are about 33,000, close to 34,000 deaths in Tamil Nadu. And it is roughly, we are seeing about 3,000 to 4,000 people dying every day still in Tamil Nadu. Not in Tamil Nadu, in India, I apologize. So because of this tremendous severity of this pandemic, drove the countries with money to develop vaccines, because that is the reason, that's the one and only reason why we got vaccines such a hurry, because the countries that were affected were the European and US, and where there is they have the financial capabilities and capacity to develop a vaccine. And as a result, we got many vaccines that were developed. And as you can see, as of July, there are 53 vaccines in the phase 1, 39 in phase 2 trials, and 32 in phase 3. 11 of them have been approved for limited use, and 8 of them have been approved for full use. And the 8 includes Moderna, Pfizer, AstraZeneca, Sinopharm, Sinovac, and Sputnik, and Bharat Biotech is coming along. And 5 vaccines have already been abandoned. And these vaccine trials started literally more than a year ago. So let's look at in India what's going on. There are 13 vaccines in clinical trial in India. That includes Covovax, Covishield, Covaxin, Sputnik, AstraZeneca, that you all already been approved, and a bunch of others as well. This is very important because all the efficacy data we have to date for all the vaccines does not have enough Indian patients in the study groups. These are the leading vaccines, and Bharat Biotech has joined the leading vaccines. And these are the 5 vaccines that have been approved in India: Moderna, Oxford AstraZeneca, at Serum Institute of India, Bharat Biotech, and Sputnik, and Gamaleya vaccine. The Moderna is, of course, there have been 7 phase 3 trials, and all the trials are in the US, Canada, and Switzerland. AstraZeneca had 8 phase 3 trials, including India, which only had 1,600 participants, and they tested it in many countries. Serum Institute of India is essentially it's an AstraZeneca vaccine, except it is produced in India, so they have a different name. They call it Covishield. There's only one phase 3 trial in India with a very small number of subjects, 1,600. Bharat Biotech it made the Covaxin. We have 2 phase 3 trials in India. The first one is a very small trial, but the second one, which is an ongoing trial, involves 25,800 people, and we are looking forward to seeing the outcome of this trial involving this many subjects. Sputnik 5 had 6 phase 3 trials, including India, and I could not get the number of patients I enrolled in this particular trial. Uh, what are these vaccines made of? We just saw a Moderna vaccine, and this Moderna is a mRNA vaccine, and they also call it Spikevax. It hasn't caught up yet. AstraZeneca, Covishield, and Sputnik, all three are vectored vaccine. In other words, both all these 4 vaccines, Sputnik, Covishield, AstraZeneca, and Moderna, they are all targeting the spike protein. So it's only a sub in it, right? And Covaxin is the inactivated whole virus. In terms of how many doses we need 2 doses for all of them, and then usually 3 to 4 weeks apart, and with a lot of dosage shortage, we know that even after 6 to 8 weeks, the second dose still was able to induce a good secondary response, and in fact that has been recommended. And in terms of how efficacious these vaccines are, as you can see, it goes anywhere between 76 to 92%. And this, what that means is, let's say if it's only about 80%, then it works in 8 out of the 10 people you vaccinate, right? That's a translation. And you can see that these vaccines, even though they have low efficacy for asymptomatic COVID, but it's certainly very good protection against the severe COVID. And of course, we don't have any information on the Covishield. And Sputnik and Moderna has a higher vaccine efficacy, and against severe COVID is really very, very good. In fact, all of them are good for severe COVID. So vaccine may not protect you completely, but definitely won't kill you, right? So you should consider taking vaccine. Is India alone in her choices? In other words, India chose those 5 vaccines. You can see Covaxin, even though it's developed in India, we already have several other countries that already has agreed to use and started using. And then we also have AstraZeneca, which is all over the map. They are all over, except like the US, they haven't entered the vaccine use here. And if you look at Sputnik India and most of the Russia countries and quite a few African countries and Latin American countries. And Moderna is also have limited use. I think partly also Moderna is a much smaller company, and the amount of vaccine they can produce is slower compared to some other companies, but they certainly have been approved used in US and Canada. Now they are beginning to show up in all the other countries. I do like Moderna a lot because of all the vaccine that have the highest efficacy for Asian population. So some of you might think, what's the point of me getting a vaccine? Because this virus is mutating. So is the vaccine going to work or not to work? So I want to briefly talk about the virus evolution. We know based on the sequencing that SARS-CoV-2 virus is the human SARS-CoV-2 virus closest relative is circulating in the bat. So it's more than likely or highly likely that it came from bat. And from the bat, it entered the intermediate hosts such as monkeys, pangolins, pigs, camels, raccoons, etc. And when it is in the primary host, remember I told you that the genome of this virus is an RNA, and it has an implication because in order to replicate RNA to make more of its genome, the virus has to use its own enzyme, which is RNA polymerase. It's a RNA-dependent RNA polymerase. And this RNA polymerase do not have proofreading function. What do I mean by that? In us, in humans, and any DNA organisms, when you have a DNA polymerase, it has a proofreading function because it will make the second copy. It will stop, turn around and look back. Did I make all the right copies? And if not, it will go back, remove all the bad ones, and then restart again. It's the process. However, the RNA polymerase will make the changes and it will not correct itself. So it will have lot of single nucleotide polymorphism, but it will be stably circulating in its primary host. And then when it enters the intermediate host, it will also circulate among the intermediate host, and of course killing those animals that didn't were susceptible, and then the virus survives. And for some reason the virus jumps in either through meat, urine, or feces into humans, and the virus have not seen humans before. They don't know what to do with it, and our immune system is attacking them, and so they will continue to evolve among human. In the process, it will kill many people, all the susceptible hosts, and eventually the virus will figure out how not to kill and co in cohabit with us, and then it will start circulating in the human. It's very similar to what happened to the flu virus. Of course, we weren't alive for the flu pandemic. It's the same thing happened, and it is 1918. It killed almost 1/3 of the world population. And now what we do, we live with the flu. We have annual flu, and we have a vaccine annually to protect yourself from flu. And I hope you do. And I do get my vaccine every year. Yes, SARS-CoV-2 is mutating, and this is the latest picture. There are several variants that is, all these different variants are circulating in different countries. And this is a website you can go, and they sequence, every time they sequence a new virus, they track them and figure out in which clade they belong to. And if you focus on the various variants, and you can see that this is the Delta variant. And if you look at this line at this right here towards the end, you can see the number of the breakthrough, which what I call is the Delta virus is now the highest number of virus that's circulating, and it's continuing to mutate, continue to spread. And whereas the Alpha variant is slowing down, Gamma has slowed down quite a bit, Beta also has slowed down, and we haven't seen a Beta variant as in a recent years, in a recent days, so to speak, right? So the community who is the COVID community are watching these variants, because when these new variants arise, there is a concern. And we know we have variants of concern and variants of interest. These variants of interest are these 6 of them. Basically, I want to tell you, because by calling this variant is a Brazil variant, and you give the Brazil a bad name, like calling it a Wuhan virus. So instead, we decided to give them all a Greek name. So alpha, beta, gamma, and you can see epsilon, zeta, iota, and kappa. And let's talk about, these are of interest. They are watching these variants to see if they're going to do something drastic or not, but we are observing them. But the variants of concern, of course, they came from UK, South Africa, Brazil, and India. And particularly what is of concern is the Delta variant, right? So this originated from India. And why is it a concern? Because the original virus, it only could infect, it can infect about 3 people, right? And you can have, really infected person is sorry, it can spread to 3 people, right? The infection rate is 3. And then the alpha variant that showed up in UK, it was infection rate was 4. Whereas the Delta variant, the infection rate is 6. Not only that, the number of days of incubation is a 6 days for the original strain and the 4 days for incubation. All these have implication. Initially, we said, okay, if we vaccine 67% of the people, we will get herd immunity. With the Delta variant, you have to vaccinate 83% of the people for herd immunity. In addition to all these problems, the amount of virus in these patients is about 1,000, more than 1,000-fold higher. In other words, this virus is replicating in the individuals much faster rate, and that's making more viruses than the alpha or the beta variant. So this is the why that's a concern. So in addition to replicating very high, the symptoms, you get all the common symptoms that you see with the original virus. In addition, you also see congestion and runny nose. In other words, you have what flu-like symptoms or common cold symptoms, but they actually is your SARS-CoV-2 infection. And so the concern is, do these vaccines work? So here as a partial answer, we know that people, if you take the convalescent antibody, in other words, you take the serum from a previously infected patient and isolate their serum, and you can see that the antibody there can actually neutralize the virus in the lab. And we know that the Bharat Biotech, the Covaxin, is 65% efficacious, right? And then AstraZeneca 60%. I couldn't get any value for Serum Institute outcome, but both Gamaleya and Moderna claim that they are very good with second dose. In fact, Moderna finds that they can protect even with a single dose. You have 72% protection against Delta virus. So that is the reason why I really like Moderna. And so in India, we just talked about this already. The very high number of deaths, we already discussed that. What about the vaccine dose administered? There are about 435 million vaccine doses have been administered, but only 6.8% of the people are fully vaccinated. So it's less than 10%, which is a concern. So I'm not coming to India anytime soon, in other words. So this is then July 19th, the death is 4,871. I believe last 2 days, the death is hovering around 3,000 to 4,000 a day in India. Okay. So the problem, part of the problem in India faced is vaccine shortage. There's not enough vaccine. That was also there's a lot of other reasons. But first of all, so how do we deal with the vaccine shortage? So time interval between the first shot and second shot has been increased for both AstraZeneca and Covaxin. Another option is to mix a second dose of a different vaccine. If you remember, I told you that this Sputnik, Covishield, AstraZeneca, and Moderna, all these vaccines focus on only on one protein. So mixing them should not matter, right? And Covaxin has everything from the virus, so it's even better to mix with that, right? And that's already a small study that combined AstraZeneca and Pfizer. They used 600 patients, and now UK recommends combining these two vaccines. There's an ongoing trial that started very early because Sputnik as a single dose didn't work very well, and they combined it with AstraZeneca. Again, they both are the vector vaccine, right? The viral vaccine. And then, of course, the latest report on Moderna vaccine is that even if you give 1/4 of the recommended Moderna vaccine, and it's still very good and give you good immune response. So maybe we can take this vaccine further with give more people the vaccine. So I'm going to switch gear now to talk about drugs, right? And when people started dying, we wanted to figure out how to help them, whether we can find some drugs or not. And the first thing most companies and most people did is, can we repurpose the drugs? Take drugs that meant for something else. Can we go after SARS-CoV-2? So, and some of these drugs have been approved for emergency use, and I'm going to just briefly review some of these critical drugs. And so one of them, and all these drugs are not to kill the virus, right? Because once the virus enters, only the immune system has to take care of it. But what we can do, what happens is your body is overactive. In the process, you have a lot of inflammation. As a collateral damage, they will destroy your lung tissue. And when you destroy your lung tissue, you can't have enough oxygen and you have pulmonary failure, and among other things. And these drugs, most of them are targeting this host inflammatory response. So the first one that was approved was remdesivir, and they had a very small clinical trial. And the only thing you have to know is that in this clinical trial, what we learned is that remdesivir just helps the recovery as 10 days compared to 15 days. This is a placebo with the drug, and it only helps if you are not ventilated. Okay, it's early stages of infection. Because if you're either on ventilation, either non-invasive, the use of remdesivir is very limited. If you're already in a mechanical ventilation, remdesivir does not work at all. So don't demand remdesivir for your loved ones thinking that it's going to help them, because it's not going to help. Ivermectin has been highly touted, and quite annoyingly for me, because I'm constantly dealing with people asking me this question, why can't we use ivermectin? There was a small study in Australia that showed the lower mortality. This ivermectin was developed to use against onchocerciasis and ostrongylodiasis. Both are diseases that are caused by worms. These are the both worms, and is you only use a very single dose or a series of doses, and you have to be very careful with how much you use. And in the lab, we know that this ivermectin takes 10 times the amount to kill the SARS-CoV-2. The concern is the side effects of ivermectin. It's a neurotoxic drug, and it can breach the blood-brain barrier with inflammation, which means that the person who's taking have all kinds of side effects that are neurological. And because of that, US, they do not recommend. As far as I know, nobody recommends the drug except few people who wants to make some bugs, some money, right? And then there is this corticosteroids. Oh, the lungs are inflamed, and so we need to help to bring down the a strong immune response. So let's suppress it by giving corticosteroids. Corticosteroids will help prevent organ dysfunction and lung injury. There were 7 clinical trials done, and it's only recommended for people with the systemic for systemic use only, right? And it's only for severe and critical COVID-19. Not in use for patients with non-severe COVID-19, not to use for diabetic patients. Why? Let's look at diabetes. India used to be the diabetes capital of the world. Thanks to China, now China has taken over as the diabetic capital of the world. And let's focus on India here in the interest of time. There are 77 million people who are diagnosed with the diabetes, which means we don't know how many more are not diagnosed. And annually, you get about 1 million people dying from diabetes in India, and 1 in 11 individuals in India have diabetes. Why am I talking about diabetes, right? So this is you have a large population of diagnosed and undiagnosed diabetes, and you come to the hospital, you give steroids without thinking, what I call irrational use of steroids, and now your immune system is suppressed, and in addition to your body is damaged, there's a cytokine storm, your lungs are in an acidic medium and lot of blood in the medium, and what it contributes to? It contributes to black fungus. And what is black fungus? Black fungus is mucormycosis. It is caused by Rhizophus oryzae, right here. And it is when you grow them, you can see if you overgrow them, they make spores, and the spores are black in color. It is a rare disease in most of the world, is 1 in a million. However, 80% higher in India. India has a much higher black fungus or mucormycosis than any other country in the world. And this in a COVID-19 patients, they have a fungal overgrowth and due to the black spores. And I told you, low oxygen, high glucose, acidic medium, increased iron levels. You have a lot of, it's a perfect environment for these spores to germinate. As of today, based on one of my colleagues who is in New Delhi, who's leading the this mucormycosis for the India, Dr. Arun Chakrabarti, he tells me that there are more than 50,000 cases of patients with the black fungus. Based on limited reports, you only see it in males, and it's also mostly in India, and it can attack both active people with the active infection as well as individuals who are recovered. And this is the black fungus is basically you have an eye, there's a swelling, pain, and dripping eyelids, and you have blurred vision and lose your eyesight. And then you start you get stuffy nose and bleeding nose, and you start getting these black patches around your nose. That's basically the fungal spores under your skin. There is indeed treatment, amphotericin B. There are a couple of fungal drugs. Most of them have serious side effects. However, if you don't treat, you get 100% mortality. And if you can't, even with the treatment, often we seem to need to do amputation of your jaw if necessary to get rid of the infection. And I know personally somebody whose jaw got amputated just last month in India. So you have to protect from black fungus and lower your glucose levels, stop eating too much sweets, and eat healthy, lose weight, and losing weight always helps to bring down your glucose levels. And I can say that based on my own personal experience. Of course, consult your doctor in the interest of protecting yourself and your loved ones. Mask up and wash your hands. So get vaccinated. It is safe and effective. It can prevent deadly illness, and it's better than getting infection from a natural infection. If you don't get vaccinated, we will continue to see the deaths, and we certainly can't be next to the person we love because they're in the hospital and you don't have access to them. So this brings me to the end of my talk. I hope I give you a brief summary of the vaccine history. We talked about 2 new technologies, and then we certainly talked about the vaccines approved in India and the evolution and the variants. I hope I gave you some brief window into the vaccination status in India, antivirals and black fungus. With that, once again, thank you the organizers for inviting me, and I will stop here.
Thank you very much, ma'am. You have covered up to 19th July. Hands off to you, ma'am. And this is a highly informative information, like how we are supposed to go for vaccination is a must for our life. And thank you. And you have gone with the globally how vaccination has been done and all the other information regarding the medicines. Thank you very much, ma'am. Thank you.
Welcome. Thank you.
Thank you, ma'am. Thank you very much. We are so lucky to have a resource person like you participating in this conference. Your presence and experience gave more meaning to it. Thank you, ma'am. Thank you very much.
Thank you, Satya.
Thank you,
Appreciate your comments. Yes.
Any queries from participant side?
Ma'am?
Madhu sir, is there any question in the chat box?
Ma'am?
Yeah, Nirmala, go ahead. Go ahead, madam.
Ma'am, good morning, ma'am. I am Nirmala
Yes.
from Biotechnology Department. I am having one small question. So in US, we are maximum they are using Moderna and one more vaccine. But in
Pfizer.
India, maximum we are using this COVID shield and Covaxin we are using. So when compared to this different kind of vaccines, we are having a different opinion regarding their prevalence. So what could be the reason, ma'am, why with a single virus we are having a different opinion with the vaccines, ma'am? So maximum they are saying that this Moderna is good when compared to the other. Here in India, the Covaxin is good when compared to COVID shield.
So even though it's using the spike protein, for example, right? The formulation is different. So it's not just straight the protein itself. So the formulation and how it is delivered, like a Moderna vaccine, you inject the RNA into the skin, right? It's very different from injecting giving the virus with the DNA that goes into your body, which then has to go to the nucleus, and then it will have to induce the immune response. And on top of it, we don't know how good these vaccines are for the Indian population, because all the clinical trials, like I said earlier, the number of Indians in the clinical trials are next to nil in many of the clinical trials. So we don't know how well it works, because our genetic makeup, and I'm calling myself Indian because I'm also a Tamilian from my ancestors were from Tamil Nadu. So our genetic makeup is very different, and not alone that, our epigenetic makeup is even more different. So everything will influence how our body react to any vaccine, but ultimately it works. So I think the issue should be, does the vaccine work? And if it works only even 65%, let's get everybody vaccinated and protect, and hopefully the herd immunity will kick in, and the other 40% will, even if they get infected, it won't be such a bad one that they recover and they will have some antibody to protect. I don't know I answered your questions, but that's the best I can do.
Thank you, ma'am. Thank you, ma'am.
So, ma'am, there is a question in the chat box also, ma'am.
Yes, ma'am.
Dr. Balachandar has raised a question like whether COVID is constructed on or not.
Okay. Dr. Balachandar, COVID is the disease. So you're asking whether the virus was constructed. So the SARS-CoV-2. So seriously, this question comes up every time I give this talk. Whether it's constructed or not, it's here. So we have to handle that. There's no way to prove whether the virus was released by a lab or it is genuinely came from the bat, right? And we know many viruses, including a Nipah virus and many other viruses that jumped host when you encroach into their area. So I'm not even going to speculate, and I think it's at this point in the pandemic with so many people dying, I would rather use the money in a better ways than to try and figure out what happened. But if countries want to do that with, and even if you try to do that, there's no way, I don't think you'll ever find out, right? It's like who really killed John F. Kennedy, and you'll never know, right? It's always going to be discussed all the time. So it's for me, I apologize. I think it's not a meaningful use of money that's needed now to get people vaccinated.
Good morning, madam.
Yes, good morning.
Madam, I am Saravanan, full-time research scholar from Vinayaka Mission's College of Pharmacy, Salem. I got two doubts in my mind, madam. One fine day, they said remdesivir is going to cure COVID from, or it's going to eradicate. And suddenly, when WHO said that remdesivir is not considered as a medicine for COVID, and there is no queue for that medicine, because in Chennai, people they were fighting for that medicine, the kilometer length of queue. Now it got stopped. Then later, my second question: what happened to the 2 DG glucose? It a sachet. Layman cannot buy that. It is 999 rupees per sachet. It is almost like a ORS bucket. One fine day they say that our government also released with big function, and suddenly that has gone. We don't know where it has gone. These two questions I have in my mind, madam, because my research work is based on dengue virus using seaweed polysaccharide from seaweeds, madam. I started my work 3 years before with dengue virus, and now suddenly these two medicines have gone. Suddenly they have vanished. I don't know what has happened.
No,
Any news?
So the important thing is I showed you the data from remdesivir. So remdesivir was developed for Ebola, and it did not work very well with Ebola. And then they tried to use it in the lab for corona virus SARS-CoV-2. It seemed to work a little well, but in the laboratory setting, right? And so they started using it without clinical data. So when they actually did the clinical experiments, they actually did the human trials, and they discovered that remdesivir, it really reduces the number of days, but it doesn't really, it's not a cure. Remember, the virus is for your recovery. It's not going to get rid of the virus, it's for the recovery. And so it's really, for me, and also is you only take remdesivir, it's in the early infection. So the number, the 2DG, again, there is no clinical trials, right? There's not sufficient data to support 2DG works, but 2DG is supposed to suppress the immune system, right? Suppress the inflammation. And the same thing with ivermectin, there is no enough supporting data for it to work. And I heard just 2 days ago, one of my colleagues' father-in-law is sick in Chennai, and the doctor prescribes ivermectin. And I'm going, why? And steroids. Why? I just sit there. And so the doctors are simply prescribing without enough evidence. And then there's also the demand, the patient demands, I want this drug for my father, for my mother. What scientific basis you have? And there is so much fake news online on SARS-CoV-2 and SARS-CoV-2 drugs. Even there's a claim that ivermectin kit is supported by WHO. That's all fake news. And do check where the source of the information before you believe anything you see online.
I have a
Good morning.
question.
Okay, ma'am, you go with.
Hello. Okay. Madam, doctor, here, as soon as they took the vaccine, I think it is a Covaxin, one other actor had heart attack the next day. So even myself, husband fell ill because of vaccination. And so that because of that, many people didn't want to take the vaccine because they are frightened that they will die of heart attack after taking the vaccine. Is there any correlation?
No, there is no, there's neither correlation or causation there, because it so happened this individual died of heart attack, right? It so happened this individual had a vaccine the day before. So there is no, even they stopped AstraZeneca for a while after they started the vaccination, and then they went and looked at the people who got sick or who had certain side effects, and they all turned out to be nothing to do with the vaccine. And so it's all those things are really not true, and they don't cause heart attack, and it shouldn't cause heart attack. Even if you think about it from a scientific point of view, your immune system, how could you, unless you have some autoimmune disease or something, you could get an endocarditis. So for me, there is no basis, and none of the scientific argument makes sense. And I don't think, and that's the reason why we don't talk about it. But then people still remember, oh, this famous actor died because he had a heart attack. So happened he had a vaccine the day before.
Good morning, ma'am. I'm Dr.
Good.
Prabha Sheila. Yes,
Yes,
it was a wonderful presentation. We have many questions about the vaccine and all doubts. You clarified many of the things, but still we have some few questions. I have few questions. Is that the people who has to be vaccinated has to go and check with any other parameters? Like they say that blood pressure will influence because it is mainly directly related to the clotting factors. As ma'am told, I also heard of many people who are nearby who gets it is not attack. I think it's mainly because of blood getting clotted. Is any relationship between clot or else with blood factors?
So there was a concern that AstraZeneca was causing blood clot, and then they stopped the whole study, the whole vaccination process, and then they went and looked in detail and found it's not true. Okay, but if you do have COVID-19, then there is a possibility if you can get thrombosis, you get blood clots and all that stuff. Because what happens, it's a little bit more involved to explain. If you're interested, we can talk about it. I do have a publication in that area. But no, I think vaccine in association with blood clot is an association, not a causation.
So people with high blood pressure or low blood pressure can have vaccine.
Yes.
Will it influence?
No, I think you should have your vaccine.
Okay. Thank you, ma'am. Thanks a lot.
Yes. And again, always, if you are in doubt, if you have some clinical conditions, you are in doubt. Let's say if you're a cancer patient and you say, should I get vaccinated? So American Cancer Society, American Diabetic Association, of course, I can only speak from the American end. All those websites, those formal websites will have instructions to whether you should get vaccinated or shouldn't get vaccinated if you have certain diseases, right? So look at or you go to National Institute of Health or a Public Health England websites. They have a CDC, Center for Disease Control in the US. And there you will find specific suggestions and instructions for a certain disease, what you should and shouldn't do. Don't take my word for it, okay? And you don't have to trust me either, right? So I'll always go check WHO, CDC, Public Health England, and the specific Cancer Society, International Diabetic Society and the Mycology Society, and look at what are they recommending. Don't listen to your friends. கொஞ்சம் தமிழ்ல சொன்னவங்க சொன்னாங்க அவங்க சொன்னாங்கன்னு ஒரு ஆதாரம் இல்லாம நிறைய பேர் பேசுவாங்க. நம்ம சயின்டிஸ்டா இருக்கும்போது அதுக்கு ஆதாரம் என்னன்னு கேட்கணும். யாரு என்ன சொன்னாலும் அதுக்கு என்ன ஆதாரம் இருக்கு, அதை எப்படி நீங்க சொல்றீங்க? சாரி டாக்டர் கிறிஸ், I have to go into my language here.
As you should. Off you go.
I'm really very happy, ma'am. You're speaking in Tamil. Really happy.
நான் சுத்த தமிழ் பேசுவேன். ஸோ எப்போதுமே ஏன்னா இப்ப நான் நிறைய பேசும்போது அதே கேள்வி எல்லாருமே அதே கேள்விதான் கேட்கிறாங்க. நான் அதுக்கு அவங்களுக்கு ஆதாரம் என்ன, அதுக்கு எங்க இருந்து கேட்டீங்கன்னா somebody said, I usually end my talk with this WhatsApp culture, right? Everybody has a trigger fingers, right? You hear something, oh, எனக்கு பிடிச்சிருக்கா அனுப்புறேன். Whether I believe in Sai Baba or not, I get Sai Baba messages, right? And it's like, why? And same thing, ivermectin and this and that, and I'm like, come on, guys, hold your fingers back, right? It's not just because you love it doesn't mean everybody love it, and just because you believe it doesn't mean everybody believe it. And certainly you become vehicle to transmit fake news. So you all of you here, how many of you, 66 பேர் இருக்கீங்க, 65. Dr. Chris doesn't know what I'm talking about, right? You can stop spreading fake news. And many of you have PhDs or you are scholars, and you can be always ask the question, where did you hear from? Who is the authority who told you this? And as a scientist, and especially the young generation, be curious. Go figure out, ask, these days the knowledge at your fingertip, except you need to know how to ask the right question. You need to know whether the source of the information is trustworthy or not. And there are many sites now to test, check whether the news is fake news, the videos are fake videos, because we can make all kinds of videos. Like I'm sitting in India doing something today without me being there, and somebody else can believe that, right? Sorry for my tirade here. My apologies.
Ma'am, I am Dr. Madhusudanan from Arubadevidi Institute of Technology, ma'am. Good morning, ma'am. I have two doubts, ma'am. One thing is, recently my cousin is working as a doctor. Recently, what he is telling is, due to COVID infection, multiple thrombosis is occurring. So they are suggesting some drugs which will prevent the thrombosis and all. So in case, my first question or first doubt is, if a person is exposing or is prone for COVID in the sense, without doctor's prescription, if they can go for preventing this multiple thrombosis, like equilic gas or some other drugs can be prescribed personally. This is one thing. The second thing is, even after vaccinating, even after one dose or second dose or third dose, the people are getting affected with COVID. If so, what is the reason for the reason and why the people have to vaccinate? And one more myth, or is it true or not? I am not sure about it. If they are also saying that the vaccinated people, the COVID will not transmit from that particular person to another person. Is it true, ma'am?
Okay, so you have three questions here.
Yeah.
So let me address the first question, thrombosis. Yes, the viral infection is giving rise to thrombosis, and that's because virus makes a protein that actually will hijack the plasmin cascade, which is required for the platelets. So it's the whole it's a very complicated regulatory pathway that leads to inflammation and also a thrombosis, and this whole platelet circulation, all that is affected. It's if you're interested, just Google my name and you might find a paper that we did on that. So yes, there are how can we promote platelet dissolving the plates, right? So it's a very complicated pathway. There is certainly an interest to figure out how to do that or how to treat. There are certain drugs, I can't remember off the top of my head, that can prevent that. The second question was, after even vaccinated, some people are coming down with COVID infection, COVID, SARS-CoV-2 infection. Remember, the vaccine is 80% efficacious, right? If I say it's 80% efficacious, that means only 2 out of 10 people the vaccine will not work. So some of these people who are coming down with COVID, even after the vaccination, it's likely their vaccine didn't work. Okay. And that's why we need to have more people vaccinated so these people can be protected. A third thing, will the vaccinated person do not give the virus to the others? So it's a very tricky question, because when you are exposed to the virus, right, even if I'm vaccinated or not, the virus will try to replicate in my system. Let's say I just got exposed to the virus now and it's replicating, and then I go and spit I stock when my things, I could give it to my husband. However, it will not last very long like people who are infected the virus. It should, because when it starts to replicate, the host will take care of it, but the host might even take care of it even before replicating, right? Because the whole idea is as soon as the virus into your system, your host immune system can take care of it. So less likely to transfer, but still I don't think we have actually looked at how many vaccinated people and how long does the virus stay in the vaccinated person, and is it long enough to give the disease to the infection to another person. I don't think there are any studies that looked at that, right? Because that's a secondary. So regardless whether you're vaccinated or not vaccinated, wear your mask, don't trust anybody, anything, right? So wear your mask, doesn't matter. And especially if you have a family member who has diabetes or other conditions that predisposes them to this infection, which can lead to death, you really want to protect yourself. Wear your mask. I wear my mask, I wear my gloves. I never go out without my mask and gloves, even though 60% of US population is vaccinated.
Thank you, ma'am. Thank you very much for your valuable and highlighted things. Thank you, ma'am.
Welcome.
Ma'am, this is the last question, ma'am. Ma'am, here in India, in a famous news channel, I have saw that one person at the age of more than 70 years, he has affected many times with the COVID virus, many times, more than 20 times, that too in US. Still he is alive. How it is possible, ma'am? Even for the one time, if we are infected means we are getting so many complications. He has infected with many times that I have seen in the news channel. How it is possible, ma'am?
Well, if you're
with
getting
the
in,
he's alive, good, he's happy.
No, but
he's also one of the factor, but more than 70 years, ma'am.
70 years is very young, my dear.
Oh, thank you, ma'am.
So you know, obviously this individual has it doesn't have any comorbidities, other conditions that would affect him. His immune system is pretty good at fighting back, so he's not getting severe COVID. And if he had any other situation with the severe COVID, he may have struggled, or he may have, you know, lost his life. So there are many factors. You know, he has a good genes, right? He inherited set of good genes for him to have a healthy, long life, you know. So
once it is infected, automatically our body to develop some antibodies, no, ma'am. How it is possible
yes,
occurring again and again, ma'am?
So just because you have because of the various variants, right? So you get infected. So it's just like flu. I get vaccinated this year, next year I have to get vaccinated again because the circulating flu virus is different. And so when this SARS-CoV-2 is rapidly mutating, so the antibody generated from the first virus may not be the variant, may not work against the second variant. So that's the reason you can get infected again. In fact, in Israel, they started giving the booster vaccine. There's a third shot because they have 100% vaccination, right? Israel, they have 100% vaccination. So now they started booster vaccine against the new variants.
Thank you, ma'am.
Thank you all.
Thank you, ma'am.
Yes, go sir.
So I think it's time for closing this session. I think now the time in Florida is maybe 1:45 or 2.
Yes.
So in this late night, you have shared your knowledge with us, ma'am. So on behalf of AVIT VMRF, I really thank you for making time in your busy schedule and enlightened us in a right way about the knowledge on COVID-19 and vaccines. So once again, I thank you, ma'am. Thank you very much.
Yeah. I thank all of you. Thank you for the nice heated discussion. மன்னிக்கணும் எதுவும் தப்பா பேசியிருந்தா hopefully
It's
I'll see
lovely
you.
to hear you talk in Tamil.
Okay, ma'am. No, ma'am. Thank you very much. Thank you very much.
I do want to say one thing, Dr. Chris. I hope you somebody needs to turn off their somebody need to turn off their I apologize for not staying back and I thank you for being here for my presentation. It is 2 a.m. and I do have a very early meeting tomorrow at 8 o'clock.
It's okay,
And,
Professor. It was my pleasure to hear you.
Thank
my pleasure.
you. Yeah, bye.
Thank you, ma'am. Thank you.
Bye. Bye.
வணக்கம்.
வணக்கம். மீண்டும் சந்திப்போம்.
மீண்டும் சந்திப்போம். Yes, ma'am.
Bye.
இன்பமே சூழ்க எல்லோரும் வாழ்க.
We will not leave you. Thank you, ma'am. Thank you very much.
நன்றி நன்றி மிக்க
மிக்க நன்றி. Bye.
Bye.
Satya, Kumar.
Sir. So I may now invite Dr. R. Balaji, Research Associate, Department of Biotechnology, to introduce our chief guest for technical lectures to Dr. Chris Sotiropoulos, co-founder and CEO of Global Opportunities Commercialization, GOC, and Director of APAC Health and Managing Director of Main Stage Incubator, Australia. So we welcome you for this session, sir. And Balaji, sir, can you please give an intro?
Balaji, sir. Balaji, sir.
Ma'am, can you hear me, ma'am?
Yeah. Go.
It feels me an immense pleasure to give the introduction about the speaker for the technical session 2, Dr. Chris Sotiropoulos. So, when we see his educational background, he holds a PhD in molecular biology and also a law degree from Australian universities. And apart from that, he has been an executive training in leadership and strategies in pharmaceuticals and biotech executive training from the Harvard Business School. So right now he has been extensively expertise in global commercialization of innovative healthcare and technology product and services. He also served as a co-founder and CEO of Global Opportunities Commercialization and the director of APAC Health and managing director of Main Stage Incubator Australia, which is a private Australian company that delivers the entrepreneurship. And he is part of an international network group comprising the highest level of government, finance, global and Nike distributors, high network families, innovators, and global experts. Apart from, a scientific background, he is also practicing a lawyer, which focusing on international trade and commercial law transactions by assisting the clients to quickly grow their business, to develop their strategy, and to implement the corporate restructure for global expansions, especially in US, Europe, Africa, and Asia. So apart from that, he is also serving as a private and public governing bodies and charities in several countries, including India, Somalia, Nigeria, and Australia. He is like a very famous known international speaker, especially in the field of international affairs, national capacity building, commercialization, and entrepreneurship. So with this small introduction, Now I welcome Dr. Krish sir to to go ahead for the presentation. I will share the slide from my end, sir.
Thank you very much. Would you like me to share screen, or will you?
I'll share from my end.
Okay, wonderful. Thank you.
One sec, sir.
Sorry, sir. Sorry for the interruption. We also have one special moment left, sir. On behalf of Department of Biotechnology, I would like to invite Dr. Giri Rangasamy, Dean CSR BMRF TU, to honor the guest, Dr. Chris Sotiropoulos, with an e-memento. Balaji, sir. Thank you, sir.
Yeah.
Ma'am, please, ma'am.
Dean, ma'am, please.
Yeah. Okay, you give it.
Yeah. Yeah, we are sharing that.
Okay.
Sir,
Sir, please receive the virtual.
Thank you very much. It's my pleasure.
Yes.
Okay.
It's an honor to be here. Thank you.
Thank you, ma'am. Thank you, sir. Now the floor is all yours, sir. Thank you so much.
Thank you. Well, it brings memories back from when I was a biotechnology graduate at one of our universities many, many years ago, where we would have often discussions about science, clinical development, experimental design, interpretation of data, as well as what we're seeing today with the COVID issue. So what I'd like to talk about today is how artificial intelligence is able to be used as a tool to detect and minimize the impact of the next global pandemic. And this image captures the interaction between the virus and the piece of artificial intelligence. So I think it aptly recalls what it is that we are seeking to talk about. So next slide, please. May we move to the next slide, please?
Just a minute.
Or if you'd like, I can control it through my share screen, and that way you don't have to do it. Would that be easier for you if I did it?
Yes, sir.
Okay.
So
let me control the share screen.
Yes, sir.
Okay. So you can mute and I'll continue. Great. Okay. All right. So we've seen, as was aptly demonstrated with Professor Marthy's talk, that there is international confusion. There still is international confusion, and it's well over a year and a half since the virus has started its trek around the world. We see this poignant image of the WHO Director General, as there was lots of concern initially as to where this virus is heading, what's the transmissibility, etc. And we saw a lot of activities throughout Europe, especially. So what are the confusion factors involved here? The pandemic definition has changed. Many years ago, it was considered that a pandemic requires significant death. And when that was moved into the consciousness of the social media, then all of a sudden people are saying it's not a pandemic because we don't have a lot of people dying. Then there was the, is it real or not? It's not a virus. It's caused by who knows what, electricity, 5G, it's bacterial. What is going on? As the numbers of people infected, as the numbers of people in hospital and passing away was rising across several countries, there was a scramble. The conspiracy theories were alive and growing, thriving, as they still are. So these images here capture what I would like to convey to you as the confusion factors. We were looking to WHO. We were looking to the United Nations. In the interim, we're still conducting our affairs, very much watching the mainstream media. There is a tension that arose between commercial continuity and disease management. Now, what is commercial continuity? That is the ability to conduct commerce, the ability to get on a plane and be a tourist, the ability to have tourists come to your city during a vacation period, the impact that would have on local economy, the ability to conduct sporting events, the ability to even conduct shipping. So there was lots of tension between commercial continuity and disease management, because the leaders in disease management and public health management will always take a very different approach to the commercial continuity model. Institutional clashes we were seeing regularly. WHO, the sovereign national policies and practices, and international validation bodies. Countries were saying, no, we're going to close our borders really quickly. Others were saying, no, we're not going to close our borders yet because we need the tourism. And that's how a lot of the locals survive. We've had, and this was experienced in India, where in the pharmaceuticals area, actives produced from another country were withheld because they weren't sure whether they will be requiring that active, because they didn't know the extent of this pandemic. All these international validation bodies were having their own ideas. There was no coordination. There was no consistency. To be fair, of course, this was a once in a century event. But you know what? For a lot of people, this was a sign of what was to occur in any event. When globalization was running out of control and people were jumping on planes with poor hygiene practices from different cultures and no systems in place to provide minimum standards, then all of a sudden the possibility of transmissibility is high. And we know where we are with that. Now, institutional models. National interests clashed. There was sharing and access inequity. We were told you couldn't get your protective equipment. There weren't enough masks around. There weren't the ability to ship any perhaps known treatment options. There were many situations where significant, powerful countries were conducting deals at the point of the transport of masks and protective equipment at the airport to say, well, instead of it going to one country, I'm going to pay you twice as much and send it to my country. Lots of inequity. The scope of the impact of this pandemic is not known. And in fact, we're hearing stories constantly, every couple of weeks, variants, populations that are more susceptible, impacting different stages, categories of individuals, the young, the not so young, the elderly. This is what we experienced, but these factors are very important for what it is that we're talking about at the moment. However, cooperation can exist and has existed and still does in certain areas. For example, in military and security, there are consensus models for use, for example, of nuclear weapons, for the development of certain qualities of military equipment, biological weapons. There are mechanisms for disaster relief. When a disaster occurs in a particular part of the world, there are international bodies that fund organizations that deliver services, and they can get into those regions quickly. We've seen the same with humanitarian relief. There are very reasonably well organized machineries available through Médecins Sans Frontières, Red Cross, and other organizations, we've seen how economic zones also cooperate well as they need to, whether it's the BRICS environment, the ASEAN environment, etc. Now, the last one is a very, very historical one, which impacts both our countries, the imperial institutional model through the Commonwealth nations. All of these cooperative arrangements demonstrate to us that a logistics arm and an outcome can be developed for the next pandemic management. So what are the elements we need to look at? And the reason why this is an important presentation for ARVIT is that it focuses on the technical aspects of disease, as well as new aspects of technology, emerging platforms, being artificial intelligence, as well as cooperation mechanisms. So the health event. We need to be able to understand when someone falls ill or there's a cluster that occurs in one particular hospital in one particular region, we need to be able to capture that event somewhere and record it in a systematic manner. Then they move into a primary contact environment, whether it's your local doctor, community health centre, or local hospital. When they start seeing patterns of a spike in unusual symptoms, unusual individuals being susceptible tourists coming in, for example, particular times of the year, they need to take note. Then there's the health data capture, where we need to ensure that we have adequate diagnosis, management, and resource allocation. Now, we look back, and this is improving daily during this pandemic. And in some parts of the world, it is developing strides ahead of others. Then we see that the elements moved into government reporting, where relevant departments, whether it's health department and other logistics departments, were called in to manage the various machinations of capturing health events, primary contacts, health data capture, and the next set of steps, which was the local management. Is it real? Is it not real? Is it isolated? What's the transmissibility? Is the source local and international? And we saw how significant the information capture was in governments and sovereign nations then electing to stop international travel, restrict travel within provinces, manage certain regions, cities, suburbs, transport mechanisms. Then moving into the treatment and eradication model, where in parallel, there was then the big race. What options are available? Are the existing options that we have of value? Are they not of value? Moving then into the diagnostic development arena, there was a scramble from both private organizations, public organizations, local research institutes, could have been the ARVIT, who've said, right, that's it. Let's get our researchers involved in diagnostics to have a look at this and see what they can come up with. It was both local and international. Similarly, on the drug development, as Professor Mathi indicated in her slide, there were and still are a number of groups around the world involved. Again, some private, some public, some local, and some international. So these elements are very important because they then move to what we're going to be talking about next, which is the data capture and AI development. So we're looking for the unusual illness. As we all know, there is a significant human dynamic at play here. And this is where sometimes the pharmaceutical industry doesn't get it right, and certainly hasn't in the past. And where AI architecture and design needs to obtain the relevant data. And this, again, is where ARVIT can play a big role, because they understand the science. They understand the human factors. So there are epigenetic factors. And there was the statement earlier about the individual who's contracted COVID SARS-V2 several times, yet has survived. There are cultural factors that hasn't been teased out properly. There are socioeconomic factors. We know people who have certain diets put stress on their immune system. Therefore, the ability for them to contract a virus may be significantly higher. Gender, where's that? Where is the data on that? Age, again, we didn't know in the beginning how it would affect people under 40, shall we say, how it would affect children. And there is, in fact, little understood even today as to why younger members of our society are not affected as significantly, either in the transmissibility, the capture of the virus, the impact on their health. Health status is very important as well. So these are factors which an AI development model needs to capture. And there may be sub-factors within these. So if you don't honestly and transparently look at all the factors, and in fact, if you look even in this image of these individuals being tested, you may be able to identify significant variations in their lifestyle, which impacts on the human dynamic. So on the diagnostic side, there needs to be a connection between public and private, an ability to connect with experts, an ability to deliver data real time. So what I'm envisaging, and our group is envisaging, and even in discussions with ARVIT, we are envisaging, is a mechanism whereby there are various contact points around the world that are immediately contacted and provided data information relevant to their development of diagnostics. Now, as we know, there are various types of diagnostics, various categories, and emerging categories as well. So the ability to connect with experts and to deliver data real time, that will force innovation, both in terms of incremental as well as disruptive innovation. And one of the classic elements of innovation we have all seen is the speed at which these diagnostic tools and therapeutic and management tools and activities have been put to the test in the marketplace. And on the bottom right-hand side, there's a reference, also relatively current. Sorry, it's a year old, but it indicates back then where the drug development was. So this is end of July last year. So within 6 or 8 months, there's a whole series of companies that are developing products. The slide, the image above refers to the targets which were used in drug development and also in diagnostic development. So again, different groups trying different things simultaneously around the world in order to deliver options. Now, we know in the therapeutics area, there are different categories of medicines. Yes, we talk about the vaccines now, but in the beginning, there would have been discussions about new chemical entities, other antibodies, repurposing drugs, non-pharmaceutical avenues as well. We're forcing innovation, and this is the great thing about data capture and AI development. We will be forcing innovation because we take something unusual, and it doesn't matter where it is, whether it's China or Africa or Australia or India or London or New York, it doesn't matter. As soon as we see a spike in an unusual activity, we need to connect the data points with the diagnostics and the therapeutics area. Now, we're all learning the hard way about management, whether it's therapeutic, diagnostic, and lifestyle. So let me give you an example of therapeutic. In Australia, we're all very keen to be vaccinated. Of course, there's those that are not, but aside from those individuals, within those that are vaccinated, we started to see a few side effects. We knew side effects would exist. We saw them, but the public disproportionately attached a very high risk rate to some of these side effects, rare side effects. So therefore, that led to a rediscussion and allocation of management of therapeutics to the community. Diagnostics, they have evolved as well. The diagnostic tests that I saw last year in April are very different to the ones that are being used today. And in fact, the CDC constantly is reviewing its PCR tests, and validation of those tests have changed as well. Lifestyle, we're seeing that. We're all seeing that with lockdowns, partial lockdowns, can't do activities overseas. In my business, prior to lockdown and prior to the pandemic, if I wanted to interact with someone for a commercial deal or discussion or conference, you'd be on a plane, you'd be meeting them, you would be conducting the affairs. Now it's all changed. And even arranging for your own citizens to come back into the country in many nations around the world is almost impossible because the borders are closed. And that's a terrible thing to do to your public, but is built into the management of what is the greater good for our community. And different nations are managing their disease spread in different ways. And that is a local reality, but also an economic reality which has to come into play. So matters in India and Europe are a lot different to matters of our lifestyle in Australia as they are in the United States and parts of Africa. So what is the promise here? The promise here is that we need to capture a couple of elements here. We need to create an architecture. We need to use the smarts of identifying as many data points, as many points of science, if you will, disease, diagnosis, factors, and develop strategic planning. Now, I'm putting the challenge out to Arvid, that I think this is a wonderful opportunity to demonstrate to the world that the smarts that you have in conjunction with others are able to identify all of the necessary elements based on our learnings and our continued learnings. As they will evolve, we will have vaccines that will not work as well as others, and there's boosters and there's the next generation. We will have different protective equipment methodologies. We will have maybe home air purifiers. Maybe we'll have purifiers in public transport. Well, we'll have new technologies which arise and are implemented. But we need to have a mechanism whereby we capture what's going on real time and we feed it around the world to known experts that are able to use their smarts to come up with management solutions as well as therapeutic and diagnostic. So I think ARVIT is well placed with others internationally to look at that intelligence architecture, strategic planning, and develop the capture. Now, there are very important emerging technology platforms such as Immersify, which is an Australian company, but already in discussions with several organizations, including yours, to share their knowledge in machine learning and artificial intelligence through social incubators and entrepreneurship to work together with that first piece of the puzzle in order to put in the data points and identify practices. So let me give you an example of how this may work. The AI platform receives data from a collection source, and that could be an ARVIT Center of Excellence. That collection point captures an interesting outbreak of 5 people, maybe in, I don't know, Venice, Lagos, Chennai. It then looks at all the other mitigating factors and feeds them in and says, hang on a minute, something's going on here. We need to provide that information to governments, to shipping companies, to people who are conducting diagnostic tests, to World Health Organization, CDCs, etc., because we have to develop tests very quickly. In addition to going back to those source points and putting a ring fence, if you will, around it, or what some of our politicians call a ring of steel, where you try and localize the outbreak. And that way, we can quickly develop, or at least have a very quick handle on arriving at management as well as therapeutic and diagnostic options a lot earlier. Now, you also need relationships with key strategic partners, whether it's your local governments, the national government, the World Health Organization, major airlines, major pharmaceutical firms, biotech firms, diagnostic firms. This is also relevant for India's self-reliance model, which your Prime Minister alluded to last year, and also the new education policy, which is looking at fostering entrepreneurship. Then you need to have the implementation model, which, interestingly, I've observed an element of consistency across the 5 continents, or 4 continents, whereby there are central elements such as border closures, vaccine rollouts, masks, interim lockdowns, which come and go depending on numbers. So the opportunity for implementation exists as well. And the individual organizations now, the government platforms which are being developed for our current day management of pandemic. And when I mean current day, I mean today. They will continue to subsist in one way or the other moving forward. So their organizations we need to bring into play as well. So I would highly recommend and would be very interested in a discussion with ARVIT to develop a pilot AI model to enroll key stakeholders, the biology schools, the engineering schools, the biotech members of our participant today, and people who are lateral thinkers to develop an architecture, as well as the Immersify group, government, diagnostic therapeutic providers, and disaster relief agencies, to collectively perhaps even work on some data simulation based on the data that has been collected to date, manage assessment and prioritization, and look at data transfer across the various stakeholders. This will lead to the development of mitigation strategies, both immediate as well as a medium-term watch and act model, as well as a longer term. Now, the good news is earlier in the talk, I referred to the other silo cooperative mechanisms, which we see in military, economic, disaster relief, and humanitarian relief. Those learnings can be brought into this model as well. And I'm very confident that AI, together with the other aspects, the human elements, as well as the data capture elements, will enable an explosion of innovation, both in the biological sciences as well as disease management, but also, let me throw this in as a left field impact on our individual practices of hygiene, how we're taught about that through our family, our community, our faith. And these are factors that are critical as well, because during this pandemic, some of those factors lagged behind or didn't come on board until there was political pressure attached. They can be at the forefront as well. So the opportunity to develop the alarm and sprinkler system, I'll call it, for humanity awaits us. We have that opportunity right now through the learnings, given that we're in a pandemic and we're not going to forget about it and then because it's gone away and then go back into normal activities. We have the opportunity to engage with the various stakeholders, but ARVIT, I think, has a lead opportunity to demonstrate global leadership in this space because it has the intellectual smarts, there's no doubt about that, and come up with an AI system which can, of course, protect India, which in itself is a significant nation, but leverage the other interactions which nations have internationally. And I'm very confident that there will be elements of this which will occur. Perhaps not through us, but they will occur. But we have the opportunity now with our relationships around the world, as does ARVIT and Immersify, to develop this alarm and sprinkler system in order to make our next encounter with a pandemic one that will be not as catastrophic, both physically as well as psychologically. And I thank you all for the opportunity to speak this afternoon. And I must say, it's like being back at university. It's a lot of fun. So thank you very much.
Thank you very much, sir. It was highly informative and it has a multidisciplinary aspect for us as a biologist. And maybe this will help us in getting into IA with in a multi-dimensional thing with the computer science faculty members. Thank you very much, and it was highly informative, sir. Any queries from our participant side or from the faculty side? Ma'am? Ma'am?
Thank you, ma'am. Thank you, sir.
Thank you, my pleasure.
Thank you, sir. We are really fortunate to hear a lecture from an eminent person like you. And thank you for spending your valuable time. Thank you so much, sir.
My pleasure. Thank you.
Thank you, sir. We'll see you in the next forum. Thank you. Thank you very much.
Thank you.
Thank you for joining the inaugural session too, sir. Thank you. Can we go ahead with the next session? Dr. Prakash, sir, are you on the floor?
Shall we close the event with a vote of thanks, ma'am, so that we'll go into the technical session?
Sir is there. Prakash sir is there.
Yeah, very good morning, madam. Very good morning, madam.
Yes, sir. Welcome, sir. Welcome, sir.
Thank you very much.
We have a vote of thanks And
Sure,
we'll go
madam.
ahead.
Then followed, we start our session.
Yes,
Thank you
sir.
very much.
Thank you.
Thank you.
Sir, Madhu sir, can you please?
1 second.
Yeah.
No duty is more urgent than that of returning thanks. It's time to end the inaugural ceremony with a vote of thanks. I would like to invite Dr. J. Madhusudanan, Associate Professor, Department of Biotechnology, to propose the vote of thanks. Sir, please.
Thank you, ma'am. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special day. First of all, I would like to thank Dr. G. Selvakumar sir, Principal AVIT, for presiding over the international conference. And I also take the opportunity to express our sincere thanks on behalf of Department of Biotechnology to respected Director Sir, Dr. Satyamurthy sir, and Dean ma'am, Dean CSR ma'am, Dr. Giri Rangasamy ma'am, for gracing this occasion. Their presence today in this international conference has immensely enhanced its importance. I also thank our Honorable Chancellor, Dr. A.S. Ganesan sir, and Dr. Anuradha Ganesan ma'am, Director VMRF, for permitting us to conduct this second international conference, Recent Strategies in Biotechnology and Biosciences 2021. I also convey my regards and hearty thanks to our chief guest, Dr. Chris, co-founder and CEO of Global Opportunities Commercialization and Director of APAC Health and Managing Director of Mainstage Incubator Australia. And I also thank Professor Dr. Kalaimadi, Florida International University, Miami, Florida, USA, for accepting our invitation and act as chief guest and grace this international conference. I also thank Mr. Syed Mohammed sir, Director International Relations, Professor P. Rajshekharan sir, Deputy Registrar Administration, Dr. K. Manivannan sir, Director Industry and Academia Relations, Secretary Treasurer, GEDC, and VP sir, part-time Dr. D. Vijendra Babu sir, VP Academics ma'am, Dr. S.P. Sangeeta ma'am, and VP Admin Sir, Professor L. Prabhu, and Dr. Lakshmi Mohan Sir, Placement Officer, for helping us to host smoothly in all aspects of this international conference. I also thank our beloved HOD, Dr. R. Devika ma'am, for her constant motivation and dedication to make this event successful. And in the end, I would like again to thank all the faculties of Biotechnology Department, research associates, and the delegates and participating colleges and university authorities. Thank you again for making this event successful. I'm sure that our college, Department of Biotechnology, AVIT, will continue to get significant provision from the diverse groups in the future. Thank you.